Are we ready? Yeah, I think we're ready. Hello. Thank you for coming along today. My name's Chris Chisman. I work for a company called TEV. We have a number of brands, Master, which does DX equipment, Quartz, which is chill water, and SC Tech, which does more industrial type of equipment. Today, I'm going to talk about our A2L Solutions. And if you want to come and see us after the talk, we're in Hall 6, stand 117. Okay, so what I'm going to talk about today is a summary of the challenges of A2L refrigerants for split systems, cold drum applications, relative to charge limits, flammability limits, room sizes, and pipe runs. And what we do with our A2L system match to overcome some of these challenges, and a few case studies to look at as well. Okay, so I'm going to do a bit on the F-gas regulation really quick. I'm just going to flash through it because I'm sure you're all aware of it now. But just to give a bit of background. A bit on EN 378, which is what we've used in terms of our products and safety relative to the A2Ls. What our product is and the development of it. Some case studies. A bit of total cost of ownership with environmental benefits, and a bit about our software that we have available as well. Okay, so like I said, very briefly, you can see the F-gas phase down up there on the what would be your left. And clearly there's going to be a lot of pressure on 448, 449 moving forward, and obviously where we are with the refrigerant price trend at the moment. My personal view is obviously there's been a lot of movement to CO2. A lot of products have already gone that way, but there's also still an awful lot of the market that's still on 448, 449. And my view is that market will naturally transition over from your 448, 449 over to the A2L type refrigerants. A bit like it did a few years ago when you can see the spike back in sort of 2017, 18, when we rolled over from 404 to 448, 449. So I think the A2Ls definitely have a part to play. And looking at the phase down that Europe have agreed, I think it's going to come pretty soon. Okay, so here's a bit of a chart here. And we'll start with the bottom chart. So back in 2015, the refrigerant of choice really was 404. And that had a GWP of close to 4,000. Now, if we move over to 454C and your 455A, they have a GWP of 148, which means you're down at 4% of where we were back in 2015 if everything shifted over from 404 to the new A2Ls. But actually, if we can also reduce the amount of charge that we're using within the systems, it means, use about a third of the charge, then actually we're only at 1% of where we were. And if you look at the EU phase down in terms of where we're going, right through till 2049, we're still allowed 2.4% of where we were back in 2015. So along with other things happening, where things moving to CO2 and some things moving to hydrocarbons, there's a potential for quite a long life for the A2Ls going forwards. Right, so next slide is fairly complicated, so you're going to have to bear with me, okay? So what we have here is a snapshot of the EN 378 on here. And on the far left-hand side is the options in terms of what you can do for the charge limits for different refrigerants. And at the top, we can see number 1, which is a charge table C2, which I'll come on to in a minute. We've also got the second option, which is to do with for sealed systems, which I'm going to talk about in a moment. We then have number 3, which is for refrigeration systems class 2 and 3, which doesn't apply to A2Ls. And then obviously we've got the 150 grams, which is kind of what you have in your domestic refrigerator, which is to do with your R290 that you have in there. Now, what these caps are talking about on section 2 that I've highlighted in red is really we're talking about the equivalent kind of energy of 150 grams of hydrocarbon of R290. So, and what it does a calculation based on what the LFL is of the individual refrigerants. So on here, we've got an example using this equation, which is M1 times 4 times the LFL, which I've highlighted. And for 455A, that calculation comes at about 2.58 kilos. So what it's saying there is about 2.58 kilos is equivalent to about 150 grams of 290. And similar with 454C, that has a slightly lower LFL, it means about 1.7 kilos is equivalent to around about 150 grams of 290 refrigerant. Now within that, there is this thing that says it must be for sealed systems, which is what I'm talking about on the right. And it talks about the fact that it needs to be tested to 3 grams a year. So when you're doing testing, we're a manufacturer. When we test to 3 grams a year, basically we use a tracer gas. So we use a tracer of hydrogen gas, and that allows us to test a leakage rate of 3 grams per year. You can't really test to 3 grams a year just using to a pressure. You have to use the tracer gas to get to that level. But then also, it talks about, mechanical forces are allowed in terms of for sealed systems. And what it's saying is that it can be done with a special tool, i.e. glue. So basically what we're talking about is the actual threads on there need to be sealed with a thread sealant, and then you've got the equivalent of a sealed system within the areas of EN 378. So if we do that, we're kind of using sort of either 2.5 or 1.7 kilos of refrigerant. And within that, that's suitable. It's kind of the equivalent rules as if you're using 150 grams of hydrocarbon. Okay, now this is the separate one. This is table C2. And within table C2, the general rule, if I go across it, we've got different options within EN 378. We've got the flammability class, which is 2L. Then you've got general access, which is into shops. Then you've got supervised access and authorized access. And also you've got these occupational classes. And generally for split systems, well, it's not general, it's true. Location type 2 is for split systems. And the rule all the way down is really 20% of the LFL times the room volume. So once you go above the sort of limit in terms of the 2.5 or 1.7 kilos, and you need to use more than that, that's when you have to start using the calculation in terms of what you're allowed within the room size. Just showing a little calculation on here for our 455A. The equivalent of a 30 cubic meter room. We do 20% of the LFL times 30 cubic meters. Surprisingly enough, it's exactly the same. It's 2.586 kilos. So once you go above a 30 cubic meter room, that's when you start, you're allowed to have more refrigerant than the 2.58. So there's also a maximum cap. I've just taken here one of the examples, and on one of the examples, which I think is just general access, we're talking here on our 455A, the 16.8 kilos is the overall maximum for general access, but you're allowed more on the authorized access. And there are other methods beyond this as well that you can use. But this is kind of the easiest method to use, so will be most generally used in terms of what the option. Now, even saying that, if we look at the 2.5 kilos or the 1.7 kilos, it's still not a massive amount of refrigerant. Generally, if you have a split cold room system, you're generally using maybe 2-3 kilos anyway, because you'll have a receiver in the system. So it's like, well, how does having these kind of caps at this sort of level help us? And this is where we brought the system match to be an option for us. Okay, so what is the system match? Well, basically, we're running a cold room system, but we run it very similar to an air conditioning system. So what we've done is instead of having a big receiver in the system, we put a small receiver in the system. We move the expansion valve, and we put an electronic valve in the condensing unit, which means the interconnecting line becomes an expansion line like you would have in air conditioning. And then obviously the suction line goes back as normal. We have a microchannel condenser, and in the evaporators, we try to have as smaller tubes as possible, again, to reduce the amount of refrigerant charge. If we do this, what you'll find is you drastically reduce the amount of refrigerant. We've got basically various options of what we do within the system. We do basically for cold rooms, for freezer rooms. In the UK, cellar cooling is quite popular as well for cooling beer. And it allows us to get the charge down below, in a lot of cases, these 2.5, 1.7 limits, and enables you to switch over to A2Ls very, very easily without any of the kind of hassle that you might have thought that you would have had. Obviously, compared to CO2, which you could go to if as an alternative to the 448, the skill uplift is a lot easier. And from a cost point of view relative to CO2, the energy costs and also the actually equipment costs for small systems, they're obviously a lot more expensive, where this is a much simpler, easy rollover from your current 448, 449 over to the A2Ls. Okay. So there are different types of refrigerant out there. Obviously, you've got the two CMORS ones, which are your 454A and your 454C, and you've got your 455. Your 454A is very good in terms of capacity, has a slightly higher GWP and a slightly less LFL. Your 454C sort of gets you back under the 150. The 455 has a much better LFL, but also has quite a high glide in terms of what you use. Okay, so I'm going to show you a couple of tables now in terms of how it applies and some comparisons of some of our systems that used to run on pump down in terms of cold rooms with a receiver, and how we've changed over to the new system match. So the example at the top here is a new system match system. And you can see where I've circled. So we've got a system here doing cooling of around about 6.5 to 9.8 in the kind of on the top table on the left. And for those type of systems, where the system charges are only around about 2 kilograms up to about a 20-meter pipe run for a cold room system. So that means that's quite a large cold room in terms of what you'd require if you need sort of 8 kilowatts. But you can still do that on a 20-meter run using the system match method and keep it below the what will be a 454C, 2.5 kilos of refrigerant. And similar, if you go to the 4.6, is it 4.6? It's 5.8 actually. Then you can go up to 40 meters, and some of the smaller systems you can go even more than 40 meters, which for a lot of cold rooms is a lot more than you need. And then compare that to the bottom table, where this is our own system, where we do basically a pump down system, and you can see very quickly the limits go over your 2.5 kilos. And in that way, then you have to do more complicated calculations, use the C1 table, but also, and we can see what the minimum room size is as well. So in terms of the amount of charge, you're allowed so much charge if it leaks into the space, and that gives you the minimum room size in terms of what you're allowed to do. So that's on medium temperature. You have a similar on low temperature. On low temperature, it's harder because you generally need more refrigerant for less kilowatts. So here we can see at the top, I've got system match where up to 20 meters. We're okay, we're below the 2.5. But on at the bottom where we do a traditional pump down, it gets very difficult on the pipe run. Okay. So we also offer this. The other thing that we do as well, that's our cold room solution. We also offer systems which are digital units for, system that you can actually match them one-to-one for cabinets as well. So I was on the wrong slide there. So yes, this is an option here, just showing what we might be able to do in terms of matching with cabinets. You can do exactly the same thing. Take our system match condensing unit with the electronic valve, program it to the refrigerant type that you want, and match it direct to a one-to-one with a cabinet. And generally, although the evaporators are a bit bigger in the evaporator in the cabinets, you still reduce the refrigerant charge significantly through running it through the expansion line method. Like I said, we also, big in the UK is cellar cooling. And here's an example here where we've got a 10-meter cellar cooler doing about 2.4 kilowatts, and the actual charge requirement is only 480 grams. So it keeps the charge sizes down to an absolute minimum. So some examples of some case studies. So this is a Central England co-op in the UK. We did 4 cold rooms. There was 3 medium temperature cold rooms and 1 low temperature cold room. And the overall charge that was required across all those 4 cold rooms was only 3.2 kilos, which we were quite happy with. I mean, to be fair, they were quite short pipe runs, but in any case, it made it very easy for them to, in terms of apply it, because they knew in terms of the amount of refrigerant, it was below the amount relative to equivalent to 148 grams of hydrocarbon. And also, if it all leaked into the space, you couldn't possibly create a flammable atmosphere because there was just so little of the refrigerant being used. And then when you do a comparison relative to CO2 for these small systems, the capital cost is significantly less as if you're going to use a CO2 condensing unit, and the energy usage is significantly less as well. So overall, that means from an annual emissions point of view, it's actually greener in terms of the fact that the amount of GWP that's in the refrigerant is extremely low because you're using so little of it. But then also because of the total cost of ownership, the cost of running it, and also the cost of buying it and installing it in the first place, with the skills and everything else you need, there's a significant saving in terms of using A2L relative to CO2. And that's kind of where I am in terms of thinking that the vast majority of the market, when it comes to the 448s and 449s, everyone's fighting for business here and there, and a lot of the end users are looking for, the cheapest solution. It'll all naturally kind of roll over to the A2Ls in terms of what the options are. This was another case study that we've got. So this was a really, to be fair, it was quite a small cold room that we did, but this one was only on 380 grams. So generally anybody who's been on the tools and done, actually installed cold room systems, generally for a cold room system, you're looking at maybe at least kind of 3-4 kilos on a cold room system. But in terms of what we do, by getting the charge size down equivalent to air conditioning, it makes it so it's a lot less. Everything else in terms of the savings are all kind of relative to the previous slide. So we've had a few what customers said. I'm not going to read these out, but obviously been trialled in various places within the UK. So obviously Asda is a big one. Used to be owned as part of Walmart. They've got a series of our cold room systems installed. Also Central England Co-op have a number of our systems installed, and they're very happy with it. And obviously the Hey Deli. So we've got like big supermarkets, we've got the small supermarkets in terms of like convenience store chains, and also the small independents. All very happy in terms of what we've done and what we've offered. Doing a little comparison, we got Omega, who are a consultancy in the UK, to do a bit of a comparison for us in terms of cost of ownership. And at the moment, looking at it, in terms of the actual cost of installs, the actual A2Ls, because of it, you get a bit of energy saving in terms of using the A2Ls, but the actual initial cost is a little bit more on the A2Ls. But over in terms of total cost of ownership, you end up about the same. But then when you're doing small systems relative to CO2 or integrals because of energy, or secondary glycol systems, basically because of the energy usage or the cost, the total cost of ownership ends up being more. But then if you take like environmental and emissions, because you've got the emissions of 448, 449, if you take a general leakage rate that you might see, the environmental side of it is clearly the A2Ls are better. But then from the energy point of view at the moment, with the amount of carbon that's required to create energy, certainly, over the next, when we end up with a fully carbon neutral energy system, then the figures will change. But, right at this time, we're looking at the A2Ls being actually a better environmental option, and certainly better than air-cooled integrals or secondary glycol systems. Okay, in terms of where we are now, this is a couple of pictures of some of the equipment we had installed in Asda. We also have a selection tool where if you put in the room size that you have and also put in the amount of kilowatts you want, it will basically do a selection in terms of what, like a matched set of equipment for our indoor and outdoor units. So that's available online to be able to have a look at. And then also in the UK, we won a number of rewards over the past few years, basically for the different types of A2L equipment that we've offered, whether it be for cellar cooling or matching with cabinets or cold room systems. Okay, and that's basically everything. So like I said, thank you very much for listening. If you want to come and talk to us, we do all sorts of different types of equipment, whether it be marine. We do some stuff on CO2 as well. Come over and see us at Hall 6, stand 117. Thank you very much.